Okay. Good afternoon, everyone. As we know, there are three important exams in class 10, right? First one is obviously NTSE. Second one is the Math Olympiad. That is obviously conducted by the Homi Bhabha Institute, right? And then the third is the Junior Science Olympiad, right? For this, you need to check your eligibility date, usually, right? Because it depends on the birth dates and all. Since these are the three important examinations in class 10, we need to prepare, right? We have to learn certain additional topics. In fact, this course, this lecture is for that, for the additional preparation for these tests. Also, these topics that we'll cover up in these sort of lectures would be helpful for you in the entrance test after plus 2. So after plus 2, if you want to give JEE, it will be helpful. If you want to give NEET, it will be helpful. If you want to give CLAT or SAT or CUET for that matter, this preparation, these lectures would be immensely helpful for you. Right? Okay. So I've made that very clear that these lectures are important from an exam point of view. But there's a very important point why these lectures are important. Let's see. Why? Because my aim in these lectures would be to make you appreciate the beauty of mathematics. Mathematics is actually beautiful. It is fascinating. It is poetic. It is mind-boggling. But somewhere down the line, because of these pressure, because of the exams and all, we forget it. We forget why we study mathematics, because it is one of the most beautiful subjects. Right? So in my class, I would want to make you appreciate the beauty of it. Right? Now, appreciation comes only when you are able to do a very important thing in the class. In order to appreciate art, or in order to appreciate math, you should be able to enjoy it. Right? If you are enjoying the topic, that means you understand the basic of it. And if you understand the basic of it, you have the knowledge of that topic. Right? If you want to know something, you should be able to enjoy the topic. So it's as simple as that. So let me just take the objective of the class for these sort of lectures. That is to just have fun or to just enjoy the lecture. Yes, there would be certain points which you will struggle with, but good, struggle is good because that's how you develop your mind. So it's absolutely fine. Right? But that will not happen in the first lecture. We'll start slow. It's absolutely fine. So without further ado, let's begin the lecture. Now, what I want you to do is write a natural number in your notebook. Write it down any. Please do not write 1 or 2. Write a bigger natural number. Right? All of you do that. Now what you do is divide the number by 2. Done? People who would have taken the bigger numbers, they would be regretting, oh shit, divide. But that's fine. Now write the remainders in the notebook. Done? Now, as I can guess, there are 2 cases. Right? Whatever number you take, either the remainder is 0. Suppose I take the number 1002. The remainder is 0. Or if you take a number like 997, the remainder is 1. The only 2 possible cases over here, the remainder can be 1, so can be 0, or it can be 1. Very important point. Now, if I divide any number, right, basically when I put number in this, that is called dividend. I know that dividend is equal to divisor, which is 2, and quotient. Now wait a second, we have not written quotient. So let me take my quotient to be k. Can be anything. So my dividend is equal to divisor into quotient plus remainder. That means my number 2k plus 0. Or I can just say my number is of the form 2k. Right? Okay. Now this number, this is a dividend. Again, I can take my quotient to be k. Now this number, this dividend is actually 2 into k plus 1. Divisor into quotient plus remainder. So my number in this case was 2k plus 1. Now here k obviously refers to some whole number. That means since there were 2 cases, 2 remainders, 0 or 1, that means there are just 2 types of number or 2 forms of number, 2k or 2k plus 1. Which makes sense. 2k is a number which is divisible by 2. That means it is even. This number is definitely not divisible by 2. That means odd. We know any natural number is either even or odd. That is what I said. Even ki jagah I wrote 2k instead of odd, I just wrote 2 plus 1. Alright, so from now on I can just say any natural number is either of the form 2k or 2k plus 1. An important thing. Okay. Now, let me ask you. Suppose you have an even number, you have an odd number. If you add an even number and an odd number, the answer would be, suppose this is of the form 2k, suppose this is of the form 2, instead of k I can take q plus 1. Definitely the form of this would be plus 1. Or I can say 2r plus 1. So the answer is odd. Or you can just do it in the mind, even plus odd is obviously odd. Right? Okay, fine. Now, suppose I have two odd numbers. Right? The answer would definitely be even now. So the justification. Right? Okay. Now, next, if I ask you, tell me the type of the square of an odd number. Now I'll say, okay, type of the square of the odd number. If I take an odd number, I'll square it up. Definitely it will be an odd number. Now the question is, can you justify it? Justify it using the things that you just learned. Try to justify. Alright, now we say type of the square of an odd number. So I have an odd number. Now I know an odd number would actually look like 2k plus 1. Right? But he's not talking about the odd number. He's talking about the square of the odd number. That means 2k plus 1 whole square he is interested. Whole square I know. So this is 4k square plus 4k plus 1. Right? I need to tell you the type of it. Right? So what I can do is, I can have 2 common from them. So that is 2 into 2k square plus 2k plus 1. Right? Now clearly this is an integer. So let me write this as 2q plus 1. Now definitely 2q plus 1 is an odd number. Right? Which you justified, right? Which you said, yes, odd square would be odd only. I have justified it. Right? The square of 2k plus 1 would be of the form 2k plus 1, which is an odd number. Alright? Okay. Now tell me the type of 8 parts of an odd number. With a little bit of justification. I know you know the answer, but with a little bit of justification. I think sufficient time. Now he says 8 parts of an odd number. Now odd number looks like 2k plus 1. I want the 8th part of it. Now mind it, I do not know the binomial till now, right? Class 10. But it's okay. I know 2k plus 1 raised by 8 is nothing but I am multiplied 2k plus 1 and 2k plus 1 and 2k plus 1 so on till 8 times. This is what I mean when I say raised by 8. Right? Mind it, when I multiply it, the initial terms would always have even factors. Right? It would be divisible by 2. Try it out. Right? But the problem with the last term, that with the constant term would be 1 into 1 into 1 into 1 into 1. It never multiplied with any of these 2k terms, right? So 1 into 1 into 1 obviously would be 1. From here, obviously since, at least you will multiply 1 2k, so definitely it would be even. Right? Since this is of the form even, so I can say this is of the form 2q plus 1. Right? So I have justified that the 8th part of an odd number will also be odd. Right? And the type would be 2k plus 1. Alright? Now, let's move on to the main question. So write down, find the sum of the following series. My series is 1 plus minus 1 plus 1 plus minus 1 plus 1 plus minus 1 and so on up to n terms. So the answer, 0 and some of you would have said 1. Now careful. Now you can see 1 plus minus 1, 1 plus minus 1, right? If I combine these two, if I take two numbers at a time, the answer is 0. Two numbers at a time, answer is 0. Two numbers at a time, answer is 0. You can see that pairs are happening, right? So the question is whether I'll get complete pairs or not. That depends on the type of n, right? So any natural number, because n is the number of terms, it would be a natural number. Any natural number would either be of the form 2k or it would be of the form 2k plus 1. It would be even or odd, right? Now if it is even number, right, if it is of the form 2k, that means the pairs would be completed. The pairs would be completed when n is equal to 2k, right? So pairs would be completed, sum of first pair 0, 0, 0, 0, so on 0. The sum of the entire series would be 0. Right? Okay. Second case, when n is equal to 2k plus 1, right? That means the pairs have not been completed, right? There is incomplete pair. Now, pair में मेरे पास 1 plus minus 1 है. Pair complete नहीं हुआ. That means first sum आई होगी plus 1. We do not have the other number of it, right? The pair has not been completed. So, previous sum would be 0 because here the pairs are completed and we have an additional number which is 1. So, 0 plus 1, the sum is 1. If you have written both the answers, then only your answer is complete. Right? Okay. Let's discuss one more thing. Now, suppose I have this collection of natural numbers 1, 2, 3, 4, 5 and so on. Right? I want to find out something for the set of natural numbers. Right? I want to prove something for the set of natural numbers. But as a collective bunch, I'm unable to do so. सारे natural numbers के लिए नहीं होगा somehow. What I can do is, I can divide my natural numbers into two collections. I can say 2, 4, 6 and so on. Then I can say 1, 3, 5 and so on. Right? I needed to prove something for the entire collection. Instead of that, what I'll do is, I'll prove that thing for the even numbers first. And then I'll prove that thing for the odd numbers. If I have done this, I have done this. Have I done the entire collection of the natural numbers? The answer is yes. Because all of the numbers, either they are there or here. So if I combine these two, I'll get that collection. In fact, this is what you did in the previous question. I asked you the sum, 2 n terms, right? Collectively, I was unable to answer. So what I did was, I divided my problem into two cases, even, odd, and I got the answer. So you can divide your collection of numbers into how many parts you want to, as per the question, and solve the question. Right? Okay. This thing is done. Now, moving on. Try to write a new natural number, a brand new natural number. Please do not write 3. Do not do that. A bigger number, right? Now, just divide that number by 3 and tell me the remainder. I think we know how many remainders are possible. Right? Now, some of you would have taken the number 52. Some of you might have taken the number 900. Right? Then you might have taken the number 1004. Right? Now, if you have 52, I should have taken 57. That's better. Right? Okay. Now, if I take 57 and divide it by 3, my remainder is 0. Right? Okay. If I take the number 100, my remainder is 1. If I take the number 1004, my remainder is 2. Is there any other remainder possible when I divide the number by 3? The answer is no. Either the remainder is 0 or 1 or 2. Right? Okay. So let me talk about this number. Right? There would be some questions that we gave. So dividend is equal to divisor into quotient plus remainder. So this number is of the form 3k. Similarly, this number is of the form 3k plus 1. Similarly, this number is of the form 3k plus 2. Right? Any natural number will leave a remainder either 0 or 1 or 2. That means any natural number is either of the form 3k or 3k plus 1 or 3k plus 2. Where obviously k is a whole number. Done? Okay. Let's see. Okay, next one. Suppose, in fact, write a number greater than 50 and of the form 3k plus 2. Greater than 50 and of the form 3k plus 2. Now, most of you would have said the answer to be 53. That is how we move on, right? But we can write more. That's absolutely fine. We can have 1001. It's absolutely fine. Right? Okay. Next, write down. Write form of a natural number whose square is of the form 3q plus 1. Next form 3k plus 1, 3k plus 2. Those are called forms of the number. So just think about what sort of numbers would have the square as 3k plus 1. Do you think that would be 3k or 3k plus 1 or 3k plus 2? Check that out. Right, so I know that any natural number is either of the form 3k or 3k plus 1 or 3k plus 2. But he is not talking about the number. He is talking about the square of the number, right? So let me square it out. So 3k whole square, which is nothing but 9k square. Now, the form of this number is, because I can write 9k square as 3 into 3k. That means 3q form. Right? He says square should of the form 3q plus 1, leaving remainder 1. Do you think this is the form that I need? Absolutely not. Right? Next, 3k plus 1. My number is of the form 3k plus 1, but I want the square, so 3k plus 1. I know how to square things out, so 9k square plus 6k plus 1. Obviously from here I can have 3 common, so 3 into 3k square plus 2k plus 1. Right? Mind that this is an integer. So I can write this as 3 into some integer, let that be q, plus 1. The square of this number is of the form 3k plus 1. Form constituent is 3k plus 1. So do you need this number? The answer is yes. If the number is of the form 3k plus 1, the square would be of this form, which is the required one. Okay. Now, let me analyze this. Now, 3k plus 2 whole square, which will give me 9k square plus 12k plus 4. Now, we have to be a little bit careful. You will say, ma'am, you can take 3 common from here. But mind that here 4 is there. Right? That means my remainder can't be 4. So, what I can write is, I can write 4 as 3 plus 1. 3 was hidden in that, so get that 3 out. From here you can get 3 common. So 3 common, 3k square plus 4k plus 1 plus 1. Obviously this is an integer, that means this is of the form 3k plus 1. That means if I take the number 3k plus 2 times, the square of it would be of the form 3k plus 1. So do I need this number? The answer is yes. If the square of the number is of the form 3k plus 1, either the number is of the form 3k plus 1 or the number is of the form 3k plus 2. Right? Okay. Write on the next one. Write the form of the square of any natural number. And natural number. Obviously, when I'm talking about the form, I'm talking about divisibility by 3. So that means you need to tell me whether the square is of the form 3k or 3k plus 1 or 3k plus 2. Alright, hurry it up. I think sufficient time. Because I think the solution is on the board. I already did it. He says write the form of the square of any natural number. Any natural number? It either has to be of the form 3k or 3k plus 1 or 3k plus 2. 3 cases? A form of the square देखते हैं. In this case, the form of the square is 3k. In this case, the form of the square is 3k plus 1. In this case, the form of the square is 3k plus 1. So you take any natural number, any type of natural number, the square is either of the form 3q or 3q plus 1. A very important result which we can use straight away. So, square of any natural number, square of any natural number is either of the forms 3q or 3q plus 1. Right? It cannot have any other form. Square of the number cannot be of the form 3q plus 2. Careful. Just two forms are there. Right? Okay. So tell me then, is 1, 2, 3, 4, 5, 6, 7, 8, 5 a perfect square using the techniques that I just discussed? Come on. There are other ways also to do it, but use the theory that we are doing today. I think sufficient time. Right. Now we just established that square of any natural number is either of the form 3q or 3q plus 1. Right? I know form of the square. So let me talk about the form of this number. If this has to be a perfect square, I should know at least its form, right? Okay. So the form of the number, divide this number by 3 and get the remainder. You can do that easily. The remainder turns out to be 2. That means this is of the form 3q plus 2. This number is of the form 3q plus 2. Now mind it, this is not of the form 3q plus 1. This is not of the form 3q plus 1. Right? That means this number cannot be a perfect square. I know any perfect square is either of the form 3q or 3q plus 1. This is neither of those forms. That means this number can definitely not be a perfect square. So obviously the answer is no, because it is of the form 3q plus 2. Right? Okay. Moving on to the next one. Write the sum of the series. Write the sum of the series, which is 1 plus 2 plus minus 3, 1 plus 2 plus minus 3, plus 1 plus 2 plus minus 3, and so on, to enter. Answer? Mind it, you need to talk about all the answers, right? Now, as you can see, 1 plus 2 plus minus 3. If I take these 3, the answer is 0. If I take these 3, the answer is 0. That means if I can have triplets, my answer would be 0 itself. Triplets. So that means I can talk about n, and I know n is either of the form 3k or 3k plus 1 or 3k plus 2. If n is of the form 3k, that means the triplets would be completed, right? Because if my n is 27, the triplets would be completed. There would be 9 triplets, right? In that case, it's 0 plus 0 plus 0 and 0 and so on. The sum is 0. Right? Okay. Now, suppose my number is of the form 3k plus 1. Suppose it is 28. Then the number of terms is 28. My triplet has not been completed. 27 तक complete हुआ. 28 में I got another number. Now, triplets have been completed, but I have an additional number. That number has to be 1. Starting of the next triplet which is not completed. Right? Now, previous sum would be what? 0. Sum of all the triplets is 0. Plus 1. That means the sum is 1. Done. Now, suppose my n is 29. That means 2 terms are extra. That along with 1, I have 2. Right? Now, in the previous one, the triplets have been completed. The sum is 0. Plus 1 plus 2. That means the sum is 3. So, when n is 3k, sum is 0. When n is of the form 3k plus 1, sum is 1. When n is of the form 3k plus 2, so sum is 3. So, again, you have divided the problem into 3 parts. Again, I will point that thing out. Let me consider the collection of natural numbers. 1, 2, 3, 4, 5, and so on. Let me have one collection, 3, 6, 9, and so on. Then 1, 4, 7, and so on. Then another one can be 2, 5, 8, and so on. Right? Obviously, if I combine these three, I will get this collection itself. Right? If I am unable to solve the problem for all the natural numbers, maybe I can divide it into 3 parts, 3 equivalent parts. Right? You do it for this, you do it for this, you do it for this. As you did in the previous question. You divided your problem. Right? Okay. Let's move on to the next one. Write down. Prove 9a square minus 1 is never a perfect square. Where a is obviously a natural number. Prove that this is never a perfect square. Right? Okay, I think sufficient time. You can always pause the video and think about it. Now I know square of any natural number is either of the forms 3q or 3q plus 1. Just 2 forms. Let me check the form of this number. 9a square minus 1. Right? Now the thing is minus. In my form usually, which is it's 3k plus 0 or 3k plus 1 or 3k plus 2. It is a plus sign in between. I do not have plus sign over here. What can I do then? What I can do is, I can write minus 1 as minus 3 plus 2. Why minus 3? Why? Because I need to get 3 in the picture anyway. So this becomes 9a square minus 3 plus 2. From here you can see that I can take 3 common. So 3a square minus 1 plus 2. Now this is definitely an integer. So this is of the form 3q plus 2. The number is of the form 3q plus 2. Do you think this will be a perfect square? No. That means 9a square is never a perfect square because the form is 3q plus 2. And number of the form 3q plus 2 can never be a perfect square. Alright, next one. If A is odd and B is of the form 3q plus 1, then write the remainder when 3a plus 2b is divided by 3. Come on. I think sufficient time. Now he says A is odd, even. That means I can easily write that A is of the form 2k plus 1. B of the form it is given, that is 3k plus 1. Now he is talking about 3a plus 2b. That means he is talking about 3a and 2b. So let me make 3a first, which is multiplied by 3, so that is 6k plus 3. Now 2b is obviously multiplied by 2, that is 6q plus 2. Right? Now he says when this plus this, so this plus this, so that is 3a plus 2b is 6k plus 3 plus 6q plus 2. Then this number is divided by 3. So let me take 3 common at least. So 3 into 2k plus 1 plus 2q plus 2. This is definitely an integer, right? Or whole number. So this is 3r plus 2. I have written this number as divisor into quotient plus remainder. So the remainder in this case is 2. When I divide 3a plus 2b by 3, the remainder turns out to be 2, which is the answer. Right? So we have done beginning of Euclid's division lemma. What we are applying right now is Euclid's division lemma. Right? And we'll continue our discussion in the next lecture. Thank you, and I will see you next time.